Sir, you're on mute. Sir, you're muted.
Oh, so I said something very important, but you missed it, isn't it? No, I'm joking. I was just asking you to keep your webcams on, but I was wondering why these people are not listening to me. Okay, now I know. Happens. I'm getting older, isn't it? Yes. Keep your webcams on, all of you. Yes, Anirudh. Okay. So today I'll be solving your textbook and workbook problems. Okay. So initially I have a few textbook problems, and then we'll be going to the workbook problems. Okay. And with this, we'll be done with this chapter, and the next chapter will be kinematics. And I think next week you'll have a test on whatever we have learned so far: units and dimensions, and scalars and vectors. Okay. How do you like the test? How do you want it to be?
Sir, MCQs only.
MCQs only?
Yes, sir.
Okay. I'll try my best to keep as many MCQs as possible, but there will be places where you'll have to write down things. Okay. But if I give you MCQs, I'll make it challenging. It's not like one answer will be right. There can be multiple answers right, and such things. Okay. So you can't do that up by Mohammed and all those things and get the answer. All right. Yes. So here are the questions for today. Textbook problems. You can open your textbook. These are the end chapter exercises. So two vectors are given: 4i cap minus 3j cap plus k cap, I suppose. So somebody help me out there. I think I've made a typo over here. Is it plus k cap?
Yes, sir.
Yeah, 4i minus 3j cap plus k cap, and b vector is minus I cap plus j cap plus 4k cap. The first question asks you to find the vector sum of these two vectors. So the first vector says go 4 steps to the right, 3 steps down, 3 steps in this one, and 1 step out of the plane. K cap is a vector that is out of the plane, isn't it? So you can imagine I and j to be vectors on the floor. K vector would be a vector going towards the ceiling. So if you were to add these two vectors, what would you find? Yes, Rachit, what is A plus B? Can you tell me?
Still figuring it out, sir.
Okay, let me draw it out for you, okay? So A vector is 4i minus 3j. What does this mean, 4i minus 3j? What is 4i?
4 root 2, sir?
No. 4i cap. See, let me draw the coordinate axis for you. So here's the coordinate axis. So we have x-axis over here, the y-axis, and the z-axis, which is coming out of the plane. Is that okay? You understand what I mean by out of the plane, right? Out of the screen there. All right. So the I cap is a vector. I cap is a vector of unit magnitude along the x-axis. All right. J cap is a vector, a unit vector, which is along the y-axis, and k cap is a unit vector along the z-axis. Do you understand what unit vectors are? These are just pure directions. These are just pointers
So
in space.
Find the displacement between these and then find A, B, okay? A plus B.
Yes, correct. Now, one second, Rachit. So what does 4i mean? 4i means 4 is the magnitude of the vector and I is the direction. All right, 4i cap. So 4i cap is a vector that is 4 times as big as the I vector. This is 4i cap. Then you have minus 3j cap there, correct? See, j cap is the vector that is looking up in the y direction. Minus j cap would be a vector that is looking down. All right, along the y direction. So minus 3j would be a vector that is starts at this point and goes to has a size of 3. Do you understand?
Yes, sir.
It has a size of 3. So this is negative 3j cap. Okay. Now what is the sum of this? Sum. How do you find sums? When we say sum of these two vectors, I mean join the tail of the first vector to the head of the second vector. That's how vectors are added. Do you understand why they are added like that? No?
They have the, you told it yesterday, day before yesterday, so the right angle type needs to
No, no, no.
form that way.
Why vectors are to add have to take the tail of the first vector to the head of the second vector. Imagine these are displacement. Some vectors, they behave like that. So suppose your house is over here. You are going to some other's house, let's say Avani's house, and from Avani's house you are going to Sandra's house. Okay. So this is the road. Okay. What do we mean by displacement vector? Displacement is a vector that just concerns with the initial position where you were and the final position. All right. So first you went from A to B and then you went from B to C, let's say. What is the total displacement? Total displacement is as good as going from A to C, isn't it?
Yes, sir.
You see how I add vectors there? I add the tail of one vector to the head of the other vector. So that's not just with displacements, you can take forces as well. Forces also behave this way. Forces also behave like this. So if you have a boat in the water and if somebody is pulling it like this and somebody else is pulling it like this, which way would the boat go?
Right?
Somewhere in the middle, isn't it?
Yeah.
Yeah. So how do you get that? So you are allowed to move vectors. So move that vector to this point to apply the triangular law. See, when you join these two things, you get the direction of the what? Net force, the direction of the resulting force. All right? You understand?
Yes, sir.
So vectors are added. There are many other vectors like acceleration, velocities, and all this. All of the vectors they add the same way. You have to add them like a triangle. All right. So when I
So
say
when I work out a sum, every time if you draw a triangle and do that, you could just
you don't have to, you don't have to, you don't
Okay.
have to draw the triangles and all those things. This is just for your understanding. So what is this vector over here? This red one over here. This one.
displacement.
No, no, no. What do you call that vector? See, this is 4i minus 3j. This vector is 4i minus 3j.
Okay, so that's called 4i minus 3j.
That's called 4i minus 3j because it's obtained by adding 4i and minus 3j. Correct?
Okay.
Okay. Then what is the vector over here? A vector. It's 4i minus 3j plus k, isn't it? Plus k means what? You
One
have
step in the z-axis.
one step along the z-axis.
Z-axis.
So have one step, I can't draw it properly over here, but have one step along the z-axis, call that as k. Now add 4i minus 3j and k. So you'll get a vector that is slightly looking upwards. You understand that I can't draw it properly, but it is slightly in the upward direction like that. So that's the vector 4i minus 3j plus k. Is that okay, Rachit?
Yes, sir.
Yeah.
But then,
Now, yes.
so A is that. This is A, okay.
Yeah, this is A. This is A. 4i minus 3j plus k. We have added all those things together.
So
Vectorial.
now for B, how do you add A plus B?
Now, how do we add A plus B, right? Now, I've already shown what A is to you. What is B? Can you tell me what B looks like? Let me do it in another color. Yeah. Yeah. What does B look like?
Minus I to the left, x-axis.
Minus
One
I.
step.
So go back one step.
Go upwards one step.
Let me do it in dotted colors. So this is minus I. Then go one
Upwards
step
plus.
and then come 4 steps outward, isn't it? So it's a vector that somewhat looks like that, coming out of the plane, right? So
Yes.
what you do is, you'll have to move that vector to the head of the first vector, A vector. That's what I told you, no? See, suppose this is A vector. Suppose that's A vector. Move the B vector to the head of the A vector. And then again, join the tail of the A vector to the head of the B vector. Now, obviously, we can't draw this out. I hope you understand that I cannot draw this out for you. So, try this exercise out in 2D. In 3D, we cannot draw these triangles and show it to you. But again, you can imagine that there is a triangle formed, isn't it? I'm just joining the tips of this triangle. Is that okay? Vector
Yes.
addition means just that. Now, of course, when the values of the vector coordinates are given like this, I don't have to draw triangles and all those things. So, addition of the vectors. So let me write that down over here. So A vector plus B vector is nothing but, let's write down what A vector is. A vector is nothing but 4i cap minus 3j cap plus k cap. Plus, this plus means vector sum, not like numbers. You have to add the arrows, that's what it means. So this is minus I cap plus j cap plus 4k cap. So when you are adding vectors, I've told you, I cap, we are going 4 steps to the right, but in the second vector, we are coming 1 step back, isn't it? So the net effect is 3 steps forward. Minus 3j cap plus j cap, that is 2 steps downward.
So the answer is 3 I cap minus 2 J cap plus 5 K cap.
Yes, exactly. That's it. Now,
Yes.
can you tell me the second one? Can you
I'll
do
work it out.
Yeah. Others, go to the third one. I'm not getting to see. Oh, yes. Some of you have given me the third answer as well. Yeah. Yeah. Correct.
Sir,
Yes, Aishwarya.
can you explain first one? I didn't understand.
First one is it?
Yes, sir.
Yeah. So first one, do you look at the vector A there? What is A vector? You understand vectors, right? What does A vector mean to you? Look at that.
Yes, sir.
What does A vector? Let me just skip the K part, okay? Let me skip the K part.
Okay, sir.
There is no K part, okay? So what is A vector? 4i minus 3.
I minus 3j.
Yes, 4i minus 3j means what, Aishwarya? 4 steps to the right, correct? 4 steps to the right. Minus 3j means what? Yes,
Minus,
minus 3j. 4i minus 3. That is A vector, isn't it?
sir.
So minus 3j means 3 steps down. Correct? You understand that part?
Okay, sir.
So 4, okay. Now add these two. Add these two means you just draw a line from here to there. So this vector is 4i minus 3j. We also call it as the A vector. What is
Okay,
B vector now? B vector is from this point now, B vector. So this is A vector. B vector is minus I. Let me do it in yellow. Minus I, 1 step backward, plus J. Plus J is come 1 step up. So this vector over here is your B vector. Is that okay?
Yes, sir.
What is A plus B now? What is A plus B? Now count the number of steps that you have walked from here. This is where you started, isn't it?
Yes, sir.
Where have you ended up? You have ended up over here. See, this is your starting position. You have ended up over there. A plus B.
P.
Correct? So that's where you have ended up. How many steps to the right is that? How many steps have you totally gone to the right?
Where, sir?
How many total steps to the right have you gone? See, when you went along the A vector, you went 4 steps to the right, isn't it? 4 steps to the right. In the B vector, you came 1 step back. Look at that, minus I. You came 1 step back.
Okay, sir.
Okay, so what is the total number of steps that you walked? 3. Correct? So A
Yes,
vector,
sir.
sorry?
3J we walk.
No, 3I. 3I. Total steps walk to the right. So A
Okay,
vector
sir.
plus B vector is 4I cap minus 3J cap. This is the A vector. See, this is the A vector plus B vector is minus I plus J. So we are counting the number of steps that we walk to the right. In the first case, we walked 4 steps to the right. But in the second case, vector, we walked 1 step back. Isn't it? So what is the total number of steps that you have walked from the point O to the point P? What is this step? That is 3, isn't it?
3J, sir.
Why 3J? 3I cap. Look at that. 4I, 4 steps front, 1 step back. So how many steps is it? 3 steps to the forward. Is that okay, Aishwarya?
Yes, sir.
3 steps forward. What about the vertical distance? Along the y direction, how much have you walked? In the first vector, you went 3 steps down, isn't it? Look at that. You're going 3 steps down. See, 3 steps down. And in the B vector, how many steps are you walking upward?
Minus 2J.
Where are you saying this? Where is minus 2J? You're telling me the answer, is it?
Sir.
Yeah. So minus 3J went 3 steps down and you came 1 step up, isn't it? So what is the net distance that you have walked? 2J, minus 2J, because you're still down there, isn't it? Look at that. You're still down. See, you are over here. Correct? Now just do the same thing with 3 dimensions there. K, you also do the same thing with K direction also. Okay, you'll get the answer. What about the second one? Rachit, have you got an answer for the second one?
So is it 3I cap minus 2J cap plus 3K cap?
One second, let me check. So A vector, Aishwarya, watch this. A vector minus B
Okay,
vector.
sir.
That's what we want, isn't it?
Yes,
Aishwarya,
sir.
what is A vector? A vector is 4I cap minus 3J cap plus K cap. Correct? Minus
Yes,
B
sir.
vector. B vector is minus I cap plus J cap plus 4K cap. So we are subtracting these 2 vectors. So subtracting means what? 4I cap. I went 4 steps forward. Then we have minus of minus there. What does that make it?
So we're supposed to multiply the signs there, sir.
Yeah. It works just like your scalars.
Okay, so then it's plus. Okay, so for 5I cap, sir.
5I cap, yes. 5I cap. Do you understand why you have to multiply the signs?
Um, I don't know. I just learned it as a, as a rule.
Yeah, it's a rule, but how do vectors work like that? Sandra, Neha, anybody? Yes, Sandra.
Vectors are just like algebra, like algebraic variables.
Yeah, we have seen that
Behave like that.
they behave like that, isn't it? So, Rachit, I'll give you a solid example of this, but right now we follow it like a rule. Okay. So 5I cap minus 3 minus j, that is minus 4j cap, minus 3j cap, minus j cap, that is minus 4j cap, and plus k minus 4k, that is minus 3k cap. And that's our answer. Okay, third one there.
So is the answer minus 3 I cap plus 2 j cap minus 3 k cap?
You're looking at the third one, is it?
Yeah,
Let's see.
this C vector.
Yeah, let's see. We have to find out A vector minus B vector plus C vector such that the sum is equal to 0, isn't it? So we have to undo the displacement that A minus B does. Correct? Undo whatever A minus B does. That's what we are looking for. What vector will undo the thing? So let's see. What is A minus B? Can you tell me from the previous case what is A minus B?
Wait, sir, I lost the answer. That I wrote the wrong answer over there. So yeah.
Okay, it's 5I cap, 4I minus of minus I, that is 5I cap, minus 4J cap, and
Because
minus,
I have the answers.
yeah. No, A minus B is that, isn't it? That's
Yes,
A
sir.
minus plus C. Now, C, let me write, is C as some I component, some J component, and some K component. Any vector has these components, isn't it? But when we add this C to the A minus B vector, we must get 0. So what must be the X component of C vector, Sarvesh?
Sir, minus 5 I cap.
Minus 5. So that will undo whatever distance you have walked along the forward direction. So coming back on the X direction. Yeah.
Plus 4 J cap.
Yeah, let's come up by 4. Okay.
And plus 3 K cap.
Yeah, we undid everything that we had done before, isn't it? And that will give us 0. We are back to the starting position.
Yes, sir.
So C vector is equal to negative 5I cap, positive 4J cap plus positive 3K cap. Done. Can you see the question there? Is it clear? So given two vectors, okay, two vectors are given. Find the magnitudes and directions. Direction is to be found with the positive x-axis. I hope the question is clear. I can't zoom further than that. So given two vectors, find the magnitude and directions with respect to the x-axis. Find the magnitude, how big it is. Find the size of this vector. And also the directions. Okay, quickly, can somebody tell me the magnitude of the first vector without writing down?
5.
Yes. Sarvesh, why? Why is it 5?
Pythagoras theorem.
Pythagoras theorem, yes.
Like triplet.
Yeah, what about the second one, Sarvesh? Quick. No time to think.
12, I'm guessing much.
Avni, yes, you're right. Anirudh, what is it?
Sir, 10.
Yes, correct.
So, but we need to find the directions for those.
Yeah, we need to find the directions, what to do.
I've been trying it for long. I didn't get any yet.
Sir, I didn't get why how the A vector's magnitude is 5.
Yeah, I'll do that. I'll do that. This is
Yes.
it's not that hard, Rachit. It's just that you've not been in the class.
Yes, sir.
So A vector. Rachit, what is A vector again? Can you tell me what does it look like?
The x-axis
Yeah, x-axis. Along the x-axis we have
being positive.
how many steps? 4 steps, isn't it?
4 steps. Yes, sir.
It's 4I cap added to
Minus 3, so that goes to negative.
minus 3J cap. This is what it looks like. So A vector is what? A vector is the vector sum of this. Correct?
Yes, sir.
Okay, this is A vector, the diagonal there, right? Magnitude of the vector means what? You have to find the size of this vector, size of that arrow. Okay, you
It's like
see,
the Cartesian plane, how many centimeters it goes through, just like that?
yeah, just like that.
Okay.
It's just like that. Except that it need not be, when I say 4 I cap and 3 j cap, it need not be actual steps. These could be forces, 4 Newton along the right, 3 Newton downward. All right, it could be that. It could be speed, 4 meter per second along the x direction, or 3 meter per second along the y direction. But it doesn't matter. The method is the same. Okay.
Excuse me, sir.
Yes, Sabrish.
So then, like, what unit should we put for 5? Like, it's
Don't put any in it. Just put u.
okay, sir.
Just say u.
Sir, why you? Like, why you?
Because we don't know what this vector is, Avni.
Sir, is U supposed to stand for units?
Yeah, u is supposed to stand for units. Yeah, that's what.
Okay.
Okay, that's what you're asking. For the rest of the 3 sub questions, is 5 or 5. 1 second. Yeah, could be. Rachit, do you understand why I'm saying that this could be any vector? Now, suppose you have a car. Okay, a car that is moving at 5 meter per second along that direction. Okay, what is the speed of the car?
5 meters.
5 meter per second. Okay, it's going from here to here in 5 meter per second. All right. Now, just look at the car. So it's moving over here. Now, can you say at the same instant how much has it moved along the x-axis? Okay, let me draw. Okay. Let me complete the entire journey of the car. When the car moves along that direction, how much has it moved along the x-axis? If it goes in that direction?
Now 4.
Now 4, isn't it? It's as though the car is moving at a rate of 4 meter per second along the x-axis. And how fast is it moving along the y-axis?
3.
3 meter per second. Do you understand that? So you can, if you want to understand it better, you try to shine light in that direction. Shine light on that and just see how fast is the shadow of the car traveling on that x direction.
So I got that, but when you calculate, is there a formula or should you just use?
I didn't get you. What do you mean by formula?
Like now, without doing this triangle, if I'm directly calculating it, should I just?
Yeah, you can do that, but the formula is nothing but the Pythagorean theorem.
Oh,
The formula goes something like this. So the length of the vector A, we write it as A magnitude is equal to the square root of x square. X square is the x component squared plus y squared. You see that this is nothing but the Pythagorean theorem, isn't it?
yes.
Yeah. So you don't have to draw the triangle again and again. So this would be square root of 4 square plus minus 3 square. So this will come out to be root of 16 plus 9. Root of 16 plus 9 is 25 under the root. And this comes out to be 5 units. You can call it a formula, but it's just the Pythagorean theorem, isn't it? So what about the B vector? What about the B vector? Avani, what about the B vector?
10 units.
10 units. Why?
It's a Pythagorean triplet.
It's again a Pythagorean triplet, isn't it? I've told you that you just zoom every side of it by 2. Every side of it by 2. All right. So you see that the B vector is 6i cap plus 8j cap. 6i. So zoom the x coordinate by 2 Zoom the y coordinate by 2. Obviously, the hypotenuse also zoomed by a factor of 2. So in the previous case, we found it to be 5. Now this time we'll find it to be 10 units. Okay, now the directions. What about the directions? Have I told you the angles in the 3, 4, 5 triangle? Never told you? Angles. I think I've told you. But let me repeat it again. So A vector, let me draw it out. A vector is 4i cap plus 3j cap. I have a vague memory of telling you this, but anyway. So this is A vector. So what is this angle? That's what we need to find out, isn't it? Direction means that. Find that angle. Find the angle that the vector makes with the positive x-axis. That's what they're asking us. So you can draw it. Can somebody just whoever has a scale and a protractor, can you just construct this 3, 4, 5 triangle and see what that angle is? I could tell you the answer, but the joy of discovering is try to find it out. And once you figure it out, remember this forever. 3, 4, 5 triangle. This is a very important triangle, isn't it? Just a rough picture will do, but keep the sides 3 and 4. Yes, Vardhan, very good. Did you do it or did you just Google it, Yashwardhan?
So is it around 55?
Yeah, around 55. Yeah. Let me tell you the answer. This angle opposite to 3J, 3, is around 37 degrees.
Yes, I got that.
37, right? And angle opposite to 4, see, bigger the side, look at that. Angle would be bigger if the side is bigger, isn't it? Obviously, you have to open up more. So the largest angle is 90 degrees. There, because it is the angle opposite to the largest side of a triangle, hypotenuse. So the angles in a 3, 4, 5 triangle are 37, 53, and 90 degrees. These are approximate, of course. So the A vector makes minus 37 degrees with the positive x-axis. Why minus? Why minus?
It's given as
Minus 3j.
No, angles are always measured in the anti-clockwise fashion. Anti-clockwise fashion. Convention again, don't ask me why. If it was up to me, I would have taken clockwise as the positive. All right. So angles are measured from anti-clockwise fashion. So you have to go this way. That would be positive. But since we have gone this way, we'll call it as negative 37. Again, a convention. Because why to write right side as the positive and left side as negative?
Sir, how is it going to say the direction?
It tells me now. Now I know the size of the arrow, isn't it? What is the size of the A vector? 5.
5.
Okay. What is the direction of the, see, vector means what? It has a magnitude and a direction, isn't it? So if I tell you vector of 5 units in the direction minus 37 degrees, have I specified the vector properly? Done, no? I told you the size of the vector. I told you the direction also. It's making 37 degrees from the x-axis, right? So that will tell me the direction of the vector.
Yes, sir.
Yeah. What about the B vector? Can you do it yourself? B vector. Remember this, in the 3, 4, 5 triangle, the angles are 90, 53 and 37. And remember where to place these angles. 53 degrees opposite to 4, the side 4, and 37 opposite to the side 3.
So I found both the angles in 6, 8, 10 right triangle.
In 6, 8, what are the angles?
So 90 degree, approximately 53 and 36.
Okay, 6, 8 is what they've got, right? So 6, 8. This is similar to the 3, 4, 5 triangle, isn't it? So angles are same. Correct, Tripti?
Yes, sir.
So angles are same. So 3, 4, 5. This is 6, which is nothing but 3 into 2. 8, which is nothing but 4 into 2. And this will be 10, which is nothing but 5 into 2. So zoomed out by the factor of 2. So this angle is 90 degrees. The angle opposite to the side 4 is what I told as 53 degrees. And this angle is 37 degrees. And this vector over here is the B vector. So the B vector makes 53 degrees with the x-axis. Look at that. B vector makes 53 degrees with the x-axis. All right, done. Yeah, correct, Sandra. It's 53
So
degrees.
these are the answers for B and D and E, right?
Yeah, for these two. The magnitude is magnitude of A is 5.
Okay, sorry. Okay.
Direction is 37. Magnitude of B is 10 and direction of B is plus 53 degrees. Those are the answers. What about A plus B? What about A plus B? Rachit, can you help me out with this? Can you help me draw this, by the way?
Draw. Okay, I basically did 15U and I don't know how to draw and do it.
Yeah, you don't know how to. Yeah, okay, fine. 4 I cap minus 3j cap. This is the A vector.
B. Yes.
And then let's write the B vector. B vector is 6I cap. 6I cap plus 8j cap. And this is the B vector. So what is A plus B vector? Add the tail of A to the head of B, isn't it? See, here's the A vector. Let me highlight it. So here's the A vector. And here's the B vector. A vector plus B vector would be this red vector over here.
Give me a minute, I can calculate it.
So can you see the x component of this A plus B vector? It is from here to here, isn't it?
I think it's 5J.
How is it 5j?
Oh, sorry, I meant the y coordinate, like y
The y
coordinate.
coordinate is 5j. Yeah, correct. You can see it in the diagram, right? See, in the diagram, we are in the A vector, we are going 4 steps to the right. And in the B vector, look at that. Just let me trace it for you. A vector, you're going 4 steps to the right. And then you're going 6 steps to the right again. So you can see that clearly the x component of the A plus B vector, the red vector that is there.
10I cap minus 5J cap.
Yeah, 10I cap plus 5j cap. See?
Oh, sorry, plus.
So this component over here is 10. So 10I cap and this is plus 5j cap.
You need to find it in that unit basis.
Yeah, on the unit vector basis, this would be a plus b is equal to 10 I cap plus 5 j cap. Or if you just want to do algebraically, it is 4 plus 6, that is 10, you can see, minus 3 plus 8, which is 5. You don't have to draw it. I'd like to draw it because I like to show it that how it works. So what is the size of this a plus b vector? How big it is? So a plus b size, we write in notations a plus b with parallel things, right? Yes, Avni, how to do that?
Sir, which one?
Size of the a plus b vector. You see the red vector there, right? A plus b, that's the a plus b vector. How do you find the size of that vector?
Pythagoras theorem.
Yeah, you have to go to Mr. Pythagoras, right? So Mr. Pythagoras would say that the size of this a plus b vector is equal to 10 squared plus 5 squared. That is 100 plus 25. What is 100? The root of 125?
I just
5
did it.
root 5.
I just did it, sir, and then I just cut it off, thinking I'm wrong.
Yeah. Next time when you make a mistake, make it confidently. So yes, Neha, how to find the angle that the vector A makes with the x-axis? See, here's the x-axis, isn't it? Do you agree this is the x-axis? How do we find this angle? Is that a known triangle, by the way? Have we done this before?
No.
Are you sure? Yesterday we did the other way around, isn't it? Just draw this for me. Draw a side length of 2 and a height of 1. What am I doing? I'm drawing a similar triangle. A triangle similar to the previous in the question. You see, Rachit, I have 5 magnitude over here and 10 over here. 5 and 10 are in the ratio 1:2, isn't it? So if I find the angles for this triangle, 1 square plus 2 square, is okay. This would be root 5. That would be root 5. Correct? I just did square root of 1 square plus 2 square. If you look at this triangle over here, the same triangle has been multiplied. Let me draw it side by side so that you know what I'm talking about. So this is 2, this is 1, and this came out to be root 5. Do you see something familiar, similar about the two triangles here? One is this that I'm trying to point out to you, and the other one is this. What is similar there? Every side is multiplied by 5, isn't it? Look at that. Every side is multiplied by 5. And the shape looks exactly the same. So if you find the angle in this triangle, you have essentially found the angle in this triangle also. So here you have to draw it out. Tripti, have you got an answer to this?
No, sir.
5 by 10. It's around 30 degrees. Sandra, yeah. It's around 30 degrees. Or you can quickly Google tan inverse of 1 by 2.
Sir, it's 26 degree and 64 degree.
20.
Or close. I'm not sure.
I got the answer here as 26.56.
I put it as it's close to 27.
Yeah, you said it's close to 27, right? So
Sir, yesterday we had found out the bigger angle. It was 63 degrees. So
yeah,
I
that
just
was the other way around, isn't it? That was this triangle. The height was 2, and the base was 1. Remember, this was 2 and this was 1, or at least in that ratio. I forgot what it was. I think it was in
2
that
and 4. 2 and
2 and
4.
4. Okay, 2 and 4. Okay, ratios is what matters to us. So this comes out to be 27 degrees, as I'm told. But the correct answer is 26.56. Can I leave D and E as homework for you? Yeah, textbook problems. Second problem, D and E. I'll leave that as homework. They are similar, isn't it? Don't worry about the exam point of view. How will you find all those angles and all? You see, even I do not know. Nobody knows those angles actually. Okay, even in PUC, you won't have those angles. You are taught how to calculate it, but it's not. You're not supposed to remember those values and all.
So does that mean you're not going to ask these angle questions?
I might, just to mess with you, Sarvesh.
Suspense.
Yes. It's good to know it, isn't it? All right. So man leaves his front door, walks 1,400 meter east, 2,000 meter north, and then takes a penny from his pocket and drops it from a cliff 48-meter high. Huh.
Uh,
No, yes.
this question, the first part of this question, should we express it in the form of I cap plus J cap plus K cap?
Yeah, correct. So 1,000 meter east, 2,000 meter north, and then takes penny from his pocket and drops it from a cliff 48 meter high. So now they're asking you to describe, they are describing the coordinate system. In a coordinate system in which the positive x, y, and z axis point east, north, and up. So east in the coordinate system means the positive x-axis, north means positive y-axis, and up means what? Up means
Z axis.
the z-axis, yes. The origin being at the location of the penny as the man leaves his front door. So the origin is at the location of the penny as the man leaves his front door. So all of this has to be calculated from the front door of the man. So let me just draw the front door. Okay, that's the front door. Let's put a knob there. So that's the origin. Write down an expression using unit vectors for the displacement of the penny. Sandra, yes, you're right. Perfect. The man returns to his front door following a different path on the return trip. What is the resultant displacement for the round trip? You don't have to write this thing down. Just tell me, Anirudh, yes. Anirudh, what is the first vector that you write down here?
Yeah.
Sorry, what I can? I could not hear you.
Set 1,004.
Yeah, 1,400 I cap. And then he walks northward, isn't it? That is how many steps?
2,100 meters.
2,100. And then he drops a penny from the cliff that is 48-meter high. So displacement of the penny along the cliff would be, or along the downward direction would be 48. So the vector looks something like this. The vector of the penny, let me write it as P vector, is 1,400 meter I cap plus 2,100 meter J cap minus 48 meter K cap. Usually we write the meter at the end, 1,400 I cap plus 2,100 J cap minus 48 K cap. We put a bracket there and we write meter. So this is supposed to be the unit. In the previous problem I told you, right, do not write anything. Do not write a unit because we don't know what the vector is. Now we know what the vector is. Now this is the displacement vector which is measured in meters. All right, so unit is meter here. Okay, this is the penny vector. What about the second part of the question? What do you think, Avni?
Sir, why did we write negative 48?
Because look at the way the coordinate system is defined. The z-axis means up. Z-axis means up. All right.
Okay, got it.
Yeah. So we have dropped the penny, which means we are going down, isn't it? So it is minus 48 K cap. What did you mean that approximately 2000? Oh, no.
The second one.
No, wrong. Read the question again. What is the resultant displacement for the round trip?
0.
Yes, Avni, very good. 0. Resultant displacement is 0. All right. So does it make sense, Sandra?
Yes, sir.
So you go 1,400 to the east, 2,100 to the north and drop the penny. But when you come back, let's say like that. The total displacement, okay, ask where you were before. I was at the front door. Where you are right now, at the front door. So total displacement is 0. I think I've told you that joke, no? If you're born in Kankanadi Hospital and die in Kankanadi Hospital, your displacement is 0. Actually, minus 6 meter if you're buried. Okay.
I agree to that.
Yeah.
No, but if you're dead, yeah, displacement
Yeah.
is 0.
Yeah. So anyway, so try to make sure that you go out of Mangalore and settle somewhere else. A particle undergoes 3 successive displacement in a plane as follows. 4.13 meters southwest, 5.26 meter east, and 5.94 meter in a direction 64 degrees north of east. Choose the x-axis pointing east and the y-axis pointing north. Find the components of each displacement. The components of the resultant displacement. I'm going to do the B part, okay? You figure out A and C part of this question. So 4.13 meters southwest. Sriniket, what does that mean? 4.13 meters southwest. Yes, Sriniket, where are you?
So, after moving 4.13 meters southwest, from there the particle moves 5.26 meter to the east.
Yes, correct.
Thank you, sir.
So let's identify the starting position. So 4.13 meters southwest. Southwest, I've told you, exactly between south and west, isn't it? So this is, here's the south, here's the west. So go exactly between the south and west. Go 4.13 meter. 5.26 meter to the east. 5.26 meter to the east. And 5.94 meter in the direction 64 degrees north of east. 64 degrees north of east. How do we go that? How do we do that? So here's the east direction. This is the east one. Here's the north direction. Just drawing directions there. Yeah. So I have to go 64 degrees north of east. So from the north direction, I have to go 64 degrees. So that would be, and how much do I have to go? I have to go 5.94 meter. And what is my total displacement now? What is my total displacement? I started here, isn't it? That's where I started, and I've ended up over there. So the total displacement is this much. How to find that? How to find that displacement looks very hard now. Can it be found easily? Ideas? You'll need calculators for this. This is a bit hard, but I'll help you out. So look at that. So from here, we have gone a bit backward, isn't it? Look at that. In the beginning, we went a little back. How much back have we gone? Can you help me out there? 1 second. Back meaning we have gone along the west direction. By how much?
4.13 divided by root 2.
Very good. So this is 4.13. 1 second. Sorry. Sarvesh, how did she say that? How does she know that is 4.13 divided by root 2?
Trigonometry for sure.
Okay.
And Sarvesh has that evil smile on. Sarvesh has that evil smile on.
Okay, because this is purely southwest, isn't it? That's the southwest direction. Southwest means what? This angle is 45 degrees. Now you know, Sarvesh. That's 45 degrees. And we have already seen what happens in a 45 degree triangle, isn't it? So this is 4.13 divided
I
by.
was seeing 30, 60, 90, like I was remembering their sine and cos.
No, it's southwest, isn't it? That is 4.13 by root 2. And then we are going forward over here by 5.26. So what is the total displacement so far? 5.26 minus 4.13 divided by root 2, correct? And then we are going a little bit ahead over here. See, we are going a little bit ahead. But how much is that? Can somebody help me out? How much is this?
If it was 60 degrees, it would have been much more easier.
Let's take it to be 60
Oh.
degrees. Let's take it to be 60 degrees. This question is unfair actually. Let's take it to be 60 degrees. Now tell me.
5.94 divided by 2.
Is it 5.94 divided by 2? What do you think?
Yes.
Which trigonometry ratio did you use there? No, forget about trigonometry ratios. I know you're not doing
Cos
that.
of 60?
Yeah, cos of 60, yeah. Forget about trigonometry ratios. This is a triangle in which the angles are 60, 90 and 30, isn't it? So what are the ratios of the sides there? If you had a 60, 90 triangle, forget about trigonometry. We do not need that trigonometry. So if you had 60, 90, 60, 30, 90, what would be the ratios of the sides? So I'd asked you to imagine equilateral triangle, isn't it? Equilateral triangle, this would be 30 then, this would be 90 and this would be 60, correct? So equilateral triangle means all the sides are equal. So this would be a by 2 and this would be a by 2. So the side that is adjacent to 60 degrees would be half of the hypotenuse. Look at that. Side that is adjacent to 60 degrees is half of the hypotenuse. So this would be half of 5.94. Is that okay, Rachit?
Yes, sir.
That is half of 5.94. And we can find the total displacement along the x-axis. The total displacement along the x-axis. How much is that? So we went 4.13 total x displacement. So total x coordinate is 4.13 divided by root 2. We went that much back. So let me put a minus sign there. Then we went ahead by 5.26. And then we again went ahead by 5.94 by 2. So that's the total x coordinate. Trust me, this question is unfair, okay? Do not worry about this. It is unfair. Okay. What about this side over here? What about this side? The same triangle. It is root 3 by 2, isn't it? This is root 3 by 2 into 5.94. So the total y coordinate would be, okay, first we went down by 4.13 by root 2. We went down and then we came up by this much. So the total y coordinate is root 3 by 2 into 5.94 minus 4.13 divided by root 2. That's the y coordinate. All right, whatever these numbers are, we are not even going to attempt to calculate these numbers. As long as you understand what just happened there, we are good to go.
So for a second, I thought it's a maths class, like so many calculations.
Yeah, no. Calculate should not. There should not be there. Physics is just about how to calculate this. If you get that part, that's enough.
Still doesn't matter, sir. Sarvesha loves physics.
Okay. So you push a box with a force of 500 newtons. What is a newton, Sandra?
K
Yes, Sarvesh. Yeah. Tell me.
kg meter per second square.
No.
An apple in your
So holding an apple of 100 grams.
100.
That's good enough. You hold an apple of 108 grams. That's whatever weight that you feel. That's a newton. Okay. Great. Okay. Remember that. Good. So you push a box with a force of 500 newtons. So that is equal to weight of 250. That is basically how much? 50 kgs of apple. Okay, let's say it's 50 kgs of apple. 50 kgs of anything, whatever that weight is, okay, that's 500 newtons. Another person pushes the box with a force of 800 newtons directly east. What is the resultant force? So there is a box that needs to be pushed.
root 89. Sorry, I'm
Root
not
80.
sure if it's right anyway.
Yeah, okay. So somebody is pushing it this way, eastwards with a force of 800 Newton. And somebody else is pushing it this way with a force of 500 Newton. So actually, instead of two people pushing, there could be one single person pushing so as to have the same effect on the box. That's the resultant, isn't it? That's what we mean by resultant force. So which way should that force be? So the direction of that resultant force is this. Just add them vectorially, just to get the 500 Newton force over here and add it this way. Add it like the triangle. Okay. But to have the same effect as these two forces, with what strength should it pull? Or with what strength should it pull? That is obtained by the Pythagorean theorem, isn't it? So the resultant force, the magnitude of the resultant force will come out to be 500 squared plus 800 squared. So this will come out to be 500 squared, that is 2500. Oh, so 2500?
25,000, sir.
25,000. So
Two
25,
lakh 50,000, right? There are 4 zeros.
yeah, 4 zeros.
Yeah, yeah.
But it's not going to matter. Yeah, let's keep it as a 25 squared into 100 squared plus 500 or 800, right?
So 25 square or 5 squared?
So 5 square.
I was just checking you, okay? I knew that. So 5 squared,
That is nice.
yeah, into 100 square, and this is 8 square into 100 square. Yes. Now 100 square is common there, isn't it? You can factor it out. When it comes out of the square root, you've got 100. 100 square is factored out. And inside the square, what remains is 25 plus 64. 25 plus 64, which adds up to, let's see, 4 plus 5 is 9, 89. Square root of 89 units. Square root of 89 is around 9, isn't it? Square root of 81 is 9. Somewhere between 9 and 10. So let me take it as 9.5. So 950 Newton. If somebody pulls this box in that direction with a force of around 950 Newton, then the box would move in the same fashion as two people pulling it with 800 Newton and 500 Newton in the east and the north directions respectively. All right, the effect is same. That's what we mean by resultant force. All right. A river flows with a speed of 10 meter per second in northeast direction. A particular boat can propel at a speed of 20 meter per second relative to water. In which direction should the boat point in order to travel in the due west? So we want to, Nihal, yes, there is a quiz today. The quiz is on trigonometry. Simple questions. Yeah, a river flows with a speed of 10 meter per second in the northeast direction. A particular boat can propel at a speed of 20 meter per second relative to the water. in which direction should the boat point in order to travel in the due west? So let me just draw that picture out for you. So for some strange reason, our river is going to be two parallel lines. 1 second, yeah. So the river is flowing in the northeast direction. Okay, this is the river. Again, this is my north and this is my east. And the speed of the river water is what? 10 meter per second. With respect to the shore, somebody over here. What does that mean? The speed of the river is 10 meter per second. Can somebody give an intuition for that? Neha, what would it mean? 10 meter per second is the speed of the river.
It's moving 10 meters every second.
What moves 10 meter every second?
I mean, no.
The water.
Oh, yeah, the water.
Yeah, the water. So if you put a stick over here, or any floating device, if you put a stick over there, in 1 second, how far will it be? 10 meters.
10 meters.
It will be 10 meters from there, isn't it? That's what it means.
That's quite fast.
That is very fast, yeah.
I give that.
It's as fast as Usain Bolt.
No, he's faster.
He's slightly faster, yeah. So 10 meter per second. It's very good that you realize that it's very fast. Yeah, good. 10 meter per second in the northeast direction. A particular boat can propel at a speed of 20 meter per second relative to the water. Now that statement is important to me. Relative to the water. What does that mean? Relative to the water.
Frame of reference is water, which means for water the boat moves at the speed of. Which means if I'm on the shore, I can see the boat going at the speed of 10 meter per second.
No.
If you're at the shore, you can see the boat moving at 20 meter per second, right?
No.
Okay.
30.
No. All your answers are right in their own frames. Okay. So if you have this boat, this particular boat can propel at 20 meter per second means if you had still water means water is not moving now, like a pond or something, and this particular boat would move 20 meter every second in that still water. All right. Now survey said 10 meter per second. So the river is flowing at 10 meter per second this way, northeast direction. So if this boat was trying to move in the opposite direction, you have to understand that the water would take it 10 meter per second, 10 meters to the right, so towards the northeast direction. But boat itself would propel 20 meters every second. So the net motion would be how much? 10 meter per second in the southeast direction. Is that okay? In the southeast direction. But like Anirudh gave 30 meter per second as the answer. If the boat and the river both are in the same direction, then of course the boat would move 30 meters.
It's supposed to be 10 meters per second. Right?
Sorry?
The answer.
Let's see. We want the boat to move towards the east. We want the boat to move towards the east. See, in which direction should the boat point so that the boat goes eastward?
Sir, it's given westward.
Sorry? I didn't get you, Anirudh.
It's given as the boat should
Due west.
travel
Due west.
in due west. West.
Oh, I said east, is it? Okay, due west. Okay, fine. Yeah, okay.
So, but even if it is in the east direction, shouldn't
Ah.
it be 10 meter per second relative to water? Because, like, if I have a ball in a train and if I'm going in like 100 meter per second, that speed, and if I throw the ball at the speed of 10 meter per second, its total speed will be.
Your mic is off.
Myself, like, sir, like if the boat had to go in the speed of like if like the river is flowing in the direction of northeast, okay, it's going in 10 meter per second, and now if the boat also has to go in the direction northeast, then to relative to water, what is the speed of the boat?
It can go two ways. It has to go northeast, is it?
Yes, sir, like the same direction as the river is flowing.
Then it has to go along the river only, no? It can't go anywhere else. It can't point in any other direction.
But sir, in the like with the frame of reference of water, what like with the river water itself, which is flowing, like what will the boat's speed be?
20 meter per second. With respect to the river, it will be 20 meter per second, no matter in which direction it is moving. You understand
Yes.
that? With
Yes.
respect to the river, it will always be 20 meter per second, whichever direction it's moving. That's a very good question that you've asked. Okay.
Thank you, sir.
So now we have to point the boat in such a way that for this person over here who is on the shore, we see this person. For that
Yes,
person,
sir.
it has to appear that the boat is going towards the west. So it has to appear for him that the boat is going to the west. Obviously, if you point it to the west, okay, one simple solution would be point the boat towards the west. Let me draw the boat like this. Let me draw it as an arrow. Or let me, since I'm going to use, okay, red arrow is the boat. Red arrow is the boat. If I point it in the west direction, what would happen? See, I'm the boat captain. I want to go west, so I point it in the west direction. What would happen? Will I go west?
You
Will
will
I go
go
west?
between north and west.
Yeah.
Yes, Rohit, very good. River is pushing me. Look at that. This is my velocity that way. River is taking me in that way, isn't it? River is taking me along the northeast. So I'll end up going like that. I hope you understand. My boat will still be pointed to the west. My boat will still be pointed to the west. Let me draw that picture out for you.
So,
Yes.
so but here won't there be even a time factor
No, that's a surprising.
or the width of the river to see?
Yeah, all those practical cases we'll have to consider. We are assuming that the river is wide enough.
Okay.
Okay. So my boat will still be pointed like that and is still trying to move to that side. But river is pushing me along the northeast direction. So the boat will go like this. Can you imagine this? I am trying to move. My boat is looking towards the west. Sorry. My boat has to look towards the west, right? 1 second.
Yes, sir. You're right here.
Yeah. The boat is looking towards the west, but it is going also in the northeast direction. It's got west velocity, also a northeast velocity. All right. So this is not the solution that we want. So we have to point our boat in such a way that it might be looking elsewhere. It might be looking elsewhere, but it goes westwards. So if we want it to work like this, we want it to move this way. So it might be looking elsewhere. Let's say it's looking that way, but we want it to go west. So this is the west, isn't it? That's the west. We want it to go like that. Is that okay? So what should be the velocity? How should we? So if the river is small, does speed differ? Speed of the boat is fixed, no? What has that got to do with the how big the river is? Does the boat change its speed based on the size of the river? That depends on the engine of this one, right? Correct. No? What else did you ask me? Did you mean that? I think I got your question. So if this river was, let's say, slimmer like that, okay?
The boat is very small, sir.
Sorry, yeah, make the boat small then. Okay, no. Jokes aside, uh, does the answer somehow change? Is that what you're saying, Nihal? No, actually the answer doesn't change. Even if the river is not very broad, the answer would still be the same. You still have to look in that direction. You still have to look in that direction and go towards the west. The direction that you need to look at does not change. All right. Is that okay? So let's say you decided that this is the direction you need to look at, and you decided to go like that. Now suddenly if somebody moves the shows towards the river, do you suddenly have to change the direction or something? Let's say you saw that the width of the river was some d. Width of the river was some d. One second, what is wrong? Width of the river was some d, and you based on that you decided, let's say such a thing does not happen, but based on the width of the river you decided that you need to go in that direction. Now some demon comes and moves the shore towards your boat. Suddenly do you have to change the direction of the boat? Nihal, what do you think? No, right? If you go continue with that same direction, you'll reach the other end in the west direction only. Right? So it need not, the direction of the boat does not depend on the width of the river.
But sir, it sometimes depends, like if you want to reach a particular point, then you'll have to decrease or increase the angle.
Yeah, because in practical cases, the river speed won't be constant like this. Right? And the boat speed also is dependent on the handler. Boat speed also won't be constant. So in that case, you have to keep on realigning and all these things. Okay.
So physics doesn't work in practical cases?
It works in practical cases.
Sir?
This is not about calculating actual answer, okay, what will that be? But we're trying to understand nature, that's what it is. Yes, somebody said something. How much time do I have? Yeah, 15 minutes. Any answers? So the river is flowing this way. This is the speed of the river. Let me write it as VR. Speed of the river in the northeast direction. Now boat has to move. The boat has to move in the west direction only. Boat has to move in the west direction only, isn't it? Now, speed of the boat plus the speed of the river gives you the actual speed of the boat. Sorry, let me put that in proper words. There is the river speed. River is dragging the boat along its direction, isn't it? River is taking it along its direction, right? Boat has its own speed. Okay, boat has its own speed, okay, in some direction. Now if you take let's say the boat goes this way, let's say the boat goes that way, then which way, sorry, if the boat is pointing that way, that's what I mean. If the boat is pointing that way, then which way would the boat end up going according to this observer over here? Which way does it end up going? Can you imagine that? The boat is like this, but the boat is trying to go this way, but at the same time the river is dragging it this way, isn't it? So which way does it go? Somewhere in between that, isn't it? Somewhere in between, like this. It goes like that. Correct? Now we do not want this to happen. We do not want the boat to go that way, but we want the boat to go this way, towards the west. What should you do? Which way should you arrange your boat? You cannot change the direction of the river, mind you. The river is always in the northeast direction. So the river is always flowing like this.
Somewhere along the southwest.
Somewhere along the southwest. Okay, that's a good answer. Somewhere along the southwest. But let's see. If I move towards the southwest, I'll be just opposing the river flow, isn't it? Will I get to the west? Will I go towards the west? No, I'll be simply going towards the southwest. Do you understand that? I'll be simply.
But so the speed of the boat is greater, so shouldn't that count?
The boat is greater, so it will continue to move in that direction. It is like we are going off like that.
Sir,
it won't be towards the west.
Sir, between west and southwest.
Between south and?
Sorry, between west and southwest.
Between west and southwards. Okay, let's see. Between west and south. So if I go like this, you mean? If I go like that, is that what you mean?
Yes.
Okay. Now what's going to happen? Actually, I have to go at a proper angle, isn't it? Do you realize that? I can't go at any angle. I have to go at proper angle because this is 10 meter per second and this has to be 20 meter per second, isn't it? Now I can go 20 meter per second in this direction. Let me write this. I have to get the size of these arrows properly, but let me do that again. So I have 10 meter per second and 20 meter per second is supposed to be double. All right. So double the size, that's what I'm trying to draw over here. So this is 20 meter per second and this is 10 meter per second. So if I go like that, if I go perpendicular to the river, will I be going westwards? Will I be going westwards? No, you don't go westwards, right? If I go slightly to the right, will I end up in the west direction? Can you see that picture? See, when you add these two arrows, you are almost getting the west direction there, isn't it? See, the board seems to be going almost towards the west, but we want it to go completely towards the west. So what should we do? We should make the angle a little bit greater than that. So let's say that we are going like this. The size of this arrow is still 20, mind you. The size of this arrow is still 20 meter per second, but we are going at a greater angle than that, such that the sum of these two velocities, look at that, sum of 10 meter per second plus 20 meter per second is towards which direction? Oh, no, sorry. That is not the best, I'm sorry. We are still not there, 1 second. Yeah, I have to go even at a greater angle. So I have to go somewhat like this. So let me do it in yellow. Yeah, I think we've got that answer. Or have we? No, not yet, sorry. Have we got the answer now? Have we got the answer now? See, this is 20 meter per second. And that's the speed of the boat. Sorry, that's the speed of the boat. Yes, correct. So this is the speed of the boat. If you go this way, then where will you end up? Look at that. You'll end up going west. Can you see that? You're going westwards. So you have to, Avani's answer was right. You have to go in the southwest direction, but not exactly in the southwest direction. You have to go slightly to the right. Okay, so you'll end up going to the west. All right, so that's the answer to that question. Okay, if you want to find the numbers, okay, then what do you do? What exactly is the direction of the vector? How do you find that? And this is your another homework. Can you form a right angle triangle there? Think. Can you form a right angle triangle? I've told you, no, whenever you come across some new picture, try to get the old picture back. You just have to find this angle, okay? Let me just show it to you. I want you to find this angle. This angle over here. What is that angle? In what direction you have to go? So you know the sides, no? Two sides, you know. To figure out one of the angles. If you figure out one of the angles, then you are good to go. Actually, Angle can be figured out easily. This is the northeast direction, so this is 45 degrees. So this will be 135 degrees. Okay, you can figure out the angle like that. So find out. Can you do it, or do you need help? Just draw the picture again. Just draw that triangle again. So northeast. This is supposed to be west. And here's the vector of 20 meters per second. So draw a line over here as well. This is the angle that you need to figure out. Okay. How do you do that? Do you realize that these two angles are same? Why?
Alternating angles.
Alternating angles. So these two angles are same. They are equal. What else can we figure out? This angle we have figured out, right? 135 degrees. So this is 10 and this is 20. How do I figure out this side? Can't. I can figure out that side. How do I figure it out? Just complete the right angle triangle here. Just complete the right angle triangle. So this angle is 45 degrees. So these two sides are equal, right? If that is 45 degrees, this also will be 45 degrees. So those two sides will be equal. And this is given to be 10. So this will be 10 by root 2. And this will be 10 by root 2. Correct? What else can we do? No, even I'm stuck here. We could apply the Pythagorean theorem, but how will that help? Yeah, figured it out. Yes. Do you see it? This angle, right? We need to figure out that angle. If we figure out that angle, we have figured out this angle, correct? So is there any trigonometry ratio that you can use there? Is there any trigonometry ratio that you can use? Let's call this angle as theta. What is sine theta? Look at this triangle. Look at this triangle over here. It's a right angle triangle, isn't it? It's a right angle triangle here. Correct? What is sine of that angle theta? Opposite side, that is 10 by root 2 divided by 20.
20.
Divided by 20. So this will come out to be sine theta is equal to 1 by 2 root 2. Okay, not something that you are used to, isn't it? Not something that you are used to. But I can tell you that the theta is approximately equal to 22 degrees. Don't ask me how I know that. I just divided by 2. Sine 1 by, what is sine theta is equal to 1 by root 2? Theta would be how much? 45 degrees. 1 by root 2. 1 by root 2 means always 45 degrees, isn't it? So half of that. So 22 and a half. You can check it out, all right? 45 degrees, half of 45 degrees. This is half of 1 by root 2, isn't it? This is half of 1 by root 2. So I divided the angle also in half. Approximately, you won't get the correct answer. Approximately 22 degrees. So if this is 22 degrees, This also will be 22 degrees. So you need to go 22 degrees south of west. You need to go 22 degrees south of west. Okay, these are your textbook problems. Haba. Hard, isn't it? Yes, I'll end the class here.